Hello everyone, so today I wanted to go over a less ideal example of stress and shear, and the reason why this is less ideal is because if you notice our area is going to be slanted, and this doesn't necessarily make it any harder than the other problems we've went over, but I think it's worth looking over this problem as well. So let's begin by reading the problem as always. So the board is subject to a tensile force of 200 pounds. Determine the average normal and average shear stress in the wood fibers, which are oriented along a plane AA at 20 degrees with the axis of the board. So they're talking about this angle right here. So as always, let's always begin with first what's given. So we're given the tensile force of 200 pounds, we're given theta of 20 degrees, we're given the thickness of 2 inches, and we're also given the height of 4 inches. And then our next section is going to be find. So we're asked to find the shear stress and also the normal average stress. So let's analyze this problem as always. So after we make this cut AA, we're gonna obtain something that looks similar to this right here. So let's go ahead and draw that. So more or less it's going to look like that, with this being 20 degrees and the height being 4 inches and the thickness being 2 inches. So we need to find this area right here because that is the area that that will help us find the shear stress and also the normal stress. So looking at this picture, we need the side, let's call this side B and side A. So side B is nothing other than just using the right triangle. It's really easy to find, right? So this translates to this triangle right here. We have 20 degrees, we have our height of 4, and then we have our side B. So sine of 20 degrees is going to be equal to opposite over hypotenuse, right? So we have opposite, which is 4, over our hypotenuse, which is B. Therefore, B is nothing but 4 over sine of 20. So let's go ahead and plug that into our calculator and see what that equates to. So 4 divided by sine of 20. And always make sure that you are in the degree mode. So B is going to be 11.695. 695. And that's of course in inches. Now that we know side B, we already know side A because we're given the thickness of the wood. Therefore, our area is going to be A times B, which is 2 times 11.695 inches squared, and that will be equal to 23.39 inches squared. Now that we found our area, we need to go back to the problem and decompose our force P. So let's make this picture and look at how that happens. We have theta 20 degrees, and P is parallel to the horizontal plane of the beam. So we have P that's horizontal to the plane, which makes this angle right here 20 degrees as well. Alright, so now we can go ahead and decompose our force because we have the angle and also the magnitude of the force. So we are going to have, of course, the perpendicular force and the force that is going parallel to the surface area that we just found. Okay, so let's call this Py, and then let's call this px, using that coordinate system. Okay, so py is going to equal to p times sine of 20. So sine of 20 is opposite over adjacent, so sorry, opposite over hypotenuse, so hypotenuse times sine of 20 is going to give us py. Then px is going to be p over p times cosine of 20. So by plugging in 200 for p, we are going to get 200 times sine of 20, that is our py, which is 68.4 pounds. And we also do that for the px, but this time we have cosine of 20, and we get 187.94 pounds. Okay, so now we have both area and the normal force as well as the parallel force. So therefore we can go ahead and calculate our shear and stress. So for our shear, we're going to have px over area, which is 187.94 pounds, over area, which is 23.39 inches squared. And that is going to be, let me see, divided by our area. That is going to be 8.03 pound per square inch. So now let's go ahead and look at sigma, or stress. That is going to be py over area, which is going to be 68.4 pounds over area, 23.39 inches squared. So if we go ahead and do that, we're going to obtain 2.92, and that is pounds per square inch. Okay, so as I mentioned in the beginning of the video, this is really not harder than what we've been going over in the previous videos. It's just a special case, and I think it's worth mentioning. So thank you for watching, and please let me know if you have any other questions or any clarifications that I can make about this video. Thank you, have a great day.